This is the video for Geometry Lesson 1.8, Perimeter, Circumference, and Area. So we're going to be able to find the perimeter or circumference of basic shapes and to find the area of basic shapes after this lesson. So the perimeter of a polygon is defined as the sum of the lengths of its sides, kind of like the fence around an area. And then the area is the number of square units that is enclosed within. This is of a polygon, in the polygon. So here are here are four of our most common polygons: square, triangle, rectangle, and circle, and the formulas for each of the perimeter and the area for each. So these formulas will be useful. Hopefully you recognize them from middle school or just regular life. So let's move on to using these. So here is a problem that is looking for the perimeter of a rectangle. So botany club members are designing a rectangular garden for the courtyard of your school. They plan to place edging on the outside of the path. How much edging material will they need? Okay, so we have the length, or we have the dimensions of the inside of the courtyard, right? And then this is going to be the path around it. Looks like the path's going to be 4 feet wide. They want to put edging here. So let's make a little mark here. So we're trying to find this green length, like the perimeter, so how much edging needs to go around. So the first thing we need to do is figure out what's this length here. Well, if this is 4 feet, then this has to be 4 feet, and this is 4 feet too. So to go from here to here is going to be 4 plus 16 plus 4. So this is 24 feet. Okay, and then the same here. This is 4. This is 4. So 22 plus 8 is 30. So this is going to be 30 feet. Okay, and then in a rectangle, right, the opposite sides are going to be the same length. So this is also 30, and this is also 24. So in order to figure out the edging, we're going to add those all up, right? So 24 plus 30 plus 24 plus 30. This is 54, so this is 54, and if we add those together, we get 108 feet. Okay, it's still a length, so we still keep the unit feet. All right, so that is the perimeter. Here is one to try on your own. It may help to draw a picture. You want to frame a picture that's 5 inch by 7 inch with a 1 inch wide frame. Okay, so see if you can figure out the perimeter of the picture, and then what's the perimeter of the outside edge of the frame. Press pause, try this one on your own, and then check back for the solution. Okay, so here for A, the perimeter of the picture is 24 inches, and the perimeter of the outside edge of the frame is 32 inches. So hopefully you got that. Check your answer and check my solution if you didn't. All right. Moving on. Is that the end of that page? Yes. Okay. To the next slide, finding circumference. So circumference is basically the perimeter of a circle, right? The outside edge of the circle, and this is going to involve pi. So this first question says, what is the circumference of the circle in terms of pi? So in terms of pi means we figure out the number that gets multiplied by pi, so that we don't actually have to multiply our number by pi. So you'll see this in practice. It'll make a little more sense if you don't understand that part first. What is the circumference of the circle to the nearest tenth? Well, this does not have a circle. So, sorry about that. Let's draw a circle. Let's give it a radius of 4. And let's solve. So circumference is 2 pi r. Let's call this 4 meters. So we can have a unit. And so this says in terms of pi. So what we're going to do is for the circumference, we're going to plug in 4 for a radius. 2 times pi times 4 meters. Right, and then when it's asking for in terms of pi, we're just going to leave the pi on the outside. We're just going to multiply all the other numbers. So 2 times 4 is 8. And then we're going to leave it as 8 pi. That's what it means by in terms of pi. Okay, so this is 8 pi, and then we're going to, meters. Okay. So that's the first part. The second part says, what's the circumference of the circle to the nearest tenth? So now that is asking for, now let's multiply 8 times pi. So use Desmos or a calculator to do 8 times pi, and then you're going to round to the nearest tenth. And your calculator should have a pi button. You shouldn't be using 3.14. So find your pi button. So 8 times pi is going to be, circumference is going to be about 25.1327 dot dot dot. This is going to be rounded to the nearest tenth. We're going to the 1 here, and since this number is less than 5, we're going to keep the 1, so this is 25.1 meters. All right, so when the question asks you to leave it in terms of pi, you don't multiply the pi, you just multiply everything else, and then you just leave it in terms of pi. And then if it asks for you to round it to the nearest tenth, right, you do 8 times pi, or whatever number you get times pi, and then round to the nearest tenth. Okay, so these are questions for you to try on your own. Circumference of a circle with radius 24 meters in terms of pi, and then what's a circle with a diameter of diameter of 24 meters to the nearest tenth. Okay, so try those two on your own, and then check back for solutions. Okay, so for A, you should have got 48 pi meters, and then for B, you should have got 75.4 meters. And you can see here, this is when we round this, right? Because this, even though this is a 3, right, because the next number is 9, we're going to round that 3 up to 4. And again, when you have a diameter, right, this is radius 24. Diameter is 2 times the radius. So remember, there are two circumference formulas. 2 pi r is your circumference in terms of the radius. And your diameter, in terms of diameter, is pi times d, right? Because d is 2 times r. And if you need to look up these formulas, right, they're on the first page of your notes for this. Okay, so let's do problem 3. Finding perimeter in a coordinate plane. What is the perimeter of EFG? So this triangle here. Okay, so this is a triangle on the coordinate plane, so what we're going to have to do is figure out what's this distance plus this distance plus this distance, and we can use what we just learned in the last section for the distance formula to do this one. This one is basically a number line, right, because since x's are the same, right, it's just the distance between 6 and -2, and then for this one, this is just going to be the distance, -2 is the same, so distance between -3 and 3. So let's do that first. This here is, this distance is the distance on a number line, right, which is the absolute value of the difference between the two coordinates, so -3 plus 3, oh sorry, minus 3, minus 3 equals -6, which is 6. So this distance here is 6. We can also count, right? 1, 2, 3, 4, 5, 6. So this is 6. Okay, and then this one here is going to be the difference between, or the absolute value of the difference between 6 minus -2, which is going to be 6. Remember, when we have a minus and negative, we add here. This is plus 2, so this is going to be 8. Absolute value of 8, which is 8. Right, and you can see 1, 2, 3, 4, 5, 6, 7, 8. I don't want you to only count. I just want you to use it as a check if it's possible. This distance is 8. And then for this here, for this length, we're going to have to use the distance formula. So distance formula from the last section was the difference between your x's squared plus the difference between your y's squared. And then take the square root of that after you add them together. So my y, let's call this x1 and y1. Let's call this x2 and y2, so we can plug them in nicely. This is going to be, my x2 is 3, my x1 is -3, and my y2 is 6 minus my y1 is -2. So this is, let me add this. So this is 6 squared, and this is, let me add this. This is 8 squared. And what do we notice here? Right, this 6 here and this 8 are what they are here. So we could also just use the Pythagorean theorem. Right, 6 squared plus 8 squared equals this length squared. And you can take the square root of that. But we did it this way, 36 plus 64. It's 100, and the square root of 100 is 10. So this distance is 10. So the perimeter is 10 plus 6 plus 8, which is 24. Okay, so next slide you can try this on your own. So here we have a quadrilateral with vertices. So I'm giving you the points of the 4 points of the quadrilateral. What's the perimeter of JKLM? So I'm asking you to graph this first. So draw this out and then calculate the distance between each of the points or of each side, all the 4 sides, and add them up. Try this on your own and then come back for the solution. Okay, so you should have got the perimeter of 20. Here you could have just take the difference between 1 and -3 to get 4. Here you can also count the 4 and then the 7. But for this one you'd use the distance formula for, and you get 5. So when you add all 4 sides up, you should get 20. Okay, so moving on, finding the area of a rectangle. So from the first page, and hopefully you just know what the area of a rectangle is, right? But when you have a length and a width, the area of a rectangle is length times width. In this case, this question is asking, you want to make a rectangular banner that is 2.5 feet wide and 5 feet high. So in this case, we have 5 feet high, 2.5 feet wide. It's not drawn to scale. But the question's asking to the nearest square yard, how much material do you need? And since they give us to this in feet, we're going to have to convert these to yards. So let's do that now before we do the problem. So 2.5, there are 3 feet in 1 yard. So if we want to convert this, we're going to put our feet on the bottom so that our feet cancel. We have 3 of them in 1 yard. Okay, and since this is 1, we're going to multiply across. 2.5 times 1 is 2.5, and then 1 times 3 is 3. So this is, if you do 2.5 divided by 3 in your calculator, you get 0.833 yards. So that's the width. And then let's convert our 5 feet by doing the same thing. And then this becomes 5. My feet cancel over 3 yards. And if you want to get a decimal for that too, 5 over 3, you get 1.6667. Okay, so then to get the area of that, right, we're going to do 0.38333 times 1.6667. And we get 1.38, and we're rounding to the nearest yard, so square yard. So this would be about 1 yard squared. Okay, and so try this one on your own. Okay, and then push pause and then get back to check your answer. Okay, this one was a little bit easier because you only had to convert the 1 and it wasn't a fraction or a decimal. So the width changes to 9 feet, so then it's 72 feet squared. Hopefully you got that. Okay, moving on to finding the area of a circle. What's the area of circle K in terms of pi? The area of a circle from the first page is pi r squared. And since our diameter is 16, that makes our radius 8. So then we can just plug in 8 for r. It says in terms of pi, so we just have to do 8 squared, which is 64 pi. You're always going to put your number in front of the pi. And then our units are area squared, so meters squared. Okay, And try this one on your own. The diameter of a circle is 14 feet. What is the area of the circle in terms of pi? Check back for the answer. Okay, there you have it. Hopefully you got 49 pi feet squared. All right, moving on. Finding area of an irregular shape. Okay, so we're going to just kind of combine what we know about areas of different shapes. So here we have an irregular shape. We don't have a formula for this, right? But we can make other shapes, right? We then have a square, a rectangle, and a rectangle. So we can find the area of this square. Let's see, let's call these 1, 2, and 3. We made 3 different shapes. So the area of 1 is a square, so 3, right, area of a square is side squared. The side here is 3, so 3 squared. This is 9 centimeters squared. Let's change the color there. The area of the second shape, since this is, oh, this mark should not be there, sorry. This is 3, this whole thing is 9. This is 3, right, because that's across from it. This is 3 and this is 3. And that means this, and then this is 3 and this is 3. 3, 3. Oh, this should say, sorry, this should be these 2 and these 2. So it should be distinct from those. Okay, so then this area is a rectangle. So this length here is 6 and 3. So this is 6 times 3, which is 18 centimeters squared. And this length here is 9. This is 3. So 9 area of the third area is 9 times 3, which is 27. And then we can just add those all up. So 9 plus 18 is 27 plus 27 is 54 centimeters cubed, or squared, sorry, not cubed. Okay, we can also look at it here. You can do it, I mean, there's a bunch of different ways you can do this. But you could also just see, right, this area here is 9, and then this area, oops, this area is repeated, right? So there's basically 1, 2, 3, 4, 5, 6 of these same, right, they're all 9s. So you could just also do 9 times 6, which is 54. Okay, you could also make different rectangles. Anyway, the basic point of this is to break it down into shapes that you do know the area of, so that you can add, and then add them all together. All right, here should be one on your own. Yeah, so try this one on your own. I do see here that looks like there is a triangle here. I'm not trying to give this away, but we didn't talk about actually the area of a triangle, which is 1/2 base times height. So try this one on your own and push pause and then check back for the solution. Okay, so if you broke this down into a square, a rectangle, and a triangle, got the areas for those and add them together, you should get 64 feet squared. Okay, and then there's your homework for this.